Adapting to the 30-degree visual perspective by emulating the angled laparoscope, a simple and low-cost solution for basic surgical training. A number of laparoscopic training systems are available that enable handling of the optics. None are reported to have significant advantages. However, the FLS laparoscopic trainer box and 3D technical systems enable practice with angled optics. The first uses a system called camera navigation, which permits views of 0 and 30 degrees, but it cannot be used with other training systems. The second uses a camera called 30 degrees SimScope, which only provides views at 30 degrees. The Simulab trainer has a camera called SimuVision, but this only provides views at 0 degrees. A comparison of these systems is shown in the table, with the FLS system highlighted since it allows evaluation of manual skills using the FLS modules. With regard to the evaluation metrics used by different systems, several have been used to measure the development of the skills required to handle the angled laparoscope. These include the time, path length, rotation, horizontal orientation, image hold for n seconds, camera collision, and the number of targets missed. Although some systems utilize a large number of metrics, this does not necessarily indicate that they are better. In fact, there is some evidence to suggest that using fewer metrics adequately distinguishes between different levels of skill. The ability to handle and adapt to the visual perspectives generated by angled laparoscopes is crucial for skilled laparoscopic surgery. However, the control of the visual workspace depends on the ability of the camera operator, who may not be the most experienced member of the surgical team. Here we present a simple, low-cost option for surgical training that challenges the learner with static and dynamic visual perspectives at 30 degrees using a system that emulates the angled laparoscope. In the spatial location task, 3 circular discs are randomly distributed at different angles, that is, 0, 30 and 150 degrees in relation to the horizontal work plane. Each disc has a straight line and is labelled, and the line must be placed within the lines on the monitor and the disc within the circle for 4 seconds. In the transfer task, the surgeon must transfer 5 rings located on a work plane angled 30 and 150 degrees to the horizontal plane. In order to move each ring, the surgeon must manipulate the optics by moving the instrument in order to avoid the instruments going out of the field of vision. In the cutting dissection task, the surgeon cuts a 4.5 cm diameter circle marked on a surgical glove containing a balloon measuring about 5 cm in diameter, and then extracts the balloon without bursting it. Here we show the mean times taken for each trainee to complete 15 repetitions of each task compared to their own baseline performance, calculated as the first 15 repetitions. The asterisks represent the pre- or baseline performance score, that is, the first 15 repetitions, and the plus sign indicates participants with a significant difference. The participants were 2 residents each in years 1, 2 and 3, and 3 residents in year 4. We also recorded the errors made by participants in each of the tasks and compared them with their own baseline performance. Errors were defined as the number of times that the camera collided with the trainer or the testing boards, and the number of times that the task needed to be repeated. Each learner performed 50 repetitions. In conclusion, working with visual perspectives of 30 degrees requires the development of different visual and spatial abilities, that is, the development of different psychomotor abilities. Our simple and low-cost training system offers the opportunity to develop basic skills across static and dynamic visual perspectives of 30 degrees and the skills required to handle angled laparoscopes. We believe that this will effectively contribute to the development of laparoscopic skills and provide self-assessment in an objective manner without relying on the laparoscopic tower.